Hey guys, welcome back to another ARIA SK programming video, and in this video I'm going to do the second video in the AI exam tutor series, and this video is just going to talk about the marking algorithm which I'm going to use. So the main part of the AI tutor is the fact that it can actually mark student given answers and written answers using AI according to a mark scheme. That is essentially the standout feature of this and why it's going to be so useful. So in this video I'm just going to talk about some different marking algorithms which I've thought about and how it's going to mark it. But first we need to talk about what it's actually trying to do. So the student will be given a question such as this one here. This is an exam question, and this is, if you don't know, this is actually a momentum question. The reason, if you read this question, why do protective pads reduce injury when players collide? The reason is actually because, let's just do a quick physics lesson here. Force can be written as the change in momentum over time, and these protective pads compress, which means they increase the time to reduce momentum. That's constant, so therefore if the denominator increases and the numerator stays constant, we can deduce that force is inversely proportional to time, and therefore if time increases, force is going to decrease, which means impact force is also going to decrease, which reduces injuries. That's essentially the answer. And I've written out my answer here, but this is a bit more wordy and it's got a bit of misinformation which is designed to try and test the marking algorithm. So what you would do is student would write that answer here like I've done, and then this is the mark scheme. Now if the teacher was marking this, what they would do is they would just look at the mark scheme, see the first point, and what they do is try and find a point inside of a student's answer which matches it. So protective pads increase the time taken to stop. Well, you could infer it from this, but probably not. You probably wouldn't get the mark for this first point. What they would likely see is, let me just see if I can make this a bit darker. You see compression increases the time to reduce momentum. So this is probably the first marking point where you get the first mark. Okay, so we got the first mark, nice. And you can see there's alternatives but also exemptions, what you need to avoid. Then you see, so the rate of change of momentum decreases, that's the second mark, and you can see that's also been achieved, not here, this is kind of the introduction, but in this second point we can see that we've got this second mark over here, so that's where the student has achieved the second mark. And finally the third mark is just reducing the force, and you can see we've got thus decrease in force. So there's a third mark. So that's how a teacher would mark something like this, where a student's given an answer. You can see all 3 marks were achieved, and the program's actually going to hopefully be able to show the student where they achieved the marks, so that next time a student answers a similar question, they don't have to put in all of this extra information, which would save them time in an exam, and also make their answers more efficient and clearer so they can be marked by the teacher. Okay, so now that you know how this is supposed to function, let's look at a few implementations I've tried to do. So let me go to VS Code, and you can see, okay, so the first implementation is, let me just create a line here. Okay, so V1. Now what this was trying to do is, given this answer, we're going to first try and split this up into a bunch of smaller clauses. So for example, this first one would be a clause, this second line would be a clause, third line would be a clause, but this fourth point would be split up into different clauses. So this might be a clause, compression increases time to reduce momentum, then this would be a clause, decrease the rate of change of momentum, and finally this would be the last clause. And essentially we're just splitting it up into the main points, so that once we've done that, using split answer, we can compare the points. So each point would then get compared against a point in this mark scheme. So for example, we'll take this one and we'd compare it against the first one, compare it against the second one, compare it against the third one, and we do that for every point a student has made, so that we could check whether the point is, has it satisfied the mark scheme. So first of all, the time complexity of this, well, if we consider comparisons are instant, then this is going to take at least number of points student makes multiplied by the number of marking points. So this case we get 1, 2, 3, 4, 5, 6 multiplied by 3, and we might also have to account for these allows or alternative answers. So this would mean 1, 2, 3, 4, 5, 6, 7 times 6. So this is already 42 operations. It's not very efficient. That's the first issue. And the second issue is that it's difficult to accurately split up language into different points. Now, the one way I tried to do this was using let's see if I can find it, using a Python library called deep segment, and I'll try and find this. Yeah, okay, so it's here. So this is the GitHub page, and essentially what it does is it'll give you some unstructured text like this, and it just splits it into the main clauses. So I'm Batman, I live in Gotham. Like, it works pretty well here. But what I found is when I was trying to split it up into, when I was trying to split this text up, sometimes it just didn't work. Like, it just returned the exact same thing, and yeah, it just wasn't working properly. And this is a pretty crucial element, so it's quite important that it works properly. So the alternative I looked into splitting things up was just to use ChatGPT, and it actually worked a lot better. Like, for example, deep segment might have split this up into might have just not split it up at all. But if I say do the same thing into ChatGPT, so I could say something like split the following text into its let's say separate clauses, and if we do this, you can see that we've managed to get it's actually very accurate. Like, it split the text into its separate clauses, and it's better than what deep segment was able to do just given this text. So what I found was ChatGPT is actually really good for language processing tasks. Like, it's a general purpose tool, but if you're specifically using it for language purpose tasks such as splitting up things, finding meanings, it excels at that kind of thing. And the next part of the V1 algorithm was going to be, well, once we've split it up, we want to compare each point to the mark scheme. And what we could do using this is sort of similarity checking using AI. We could do text semantics. And yeah, I came up with an algorithm for this as well. Not an algorithm, but if we go to point comparison, there are different algorithms to use. I don't know if I might have deleted. Oh no, I've got it here. So yeah. One library which I might have been able to use is something called sentence transformers. Essentially, this transforms transforms text into a well, it just sort of standardized text based on its semantic meanings. So two pieces of text which have similar meanings should in theory be grouped together. However, what I found was this didn't really work like, it worked sort of well, but not very well. Like, if we found a similarity between these 2 points of text, which should be essentially the same, I was actually getting 0.35, and this is 0 to 1, so that's not even, this doesn't think these are very similar, even though they obviously are. And when you're getting those kind of huge error margins, you just can't use that. So I again did the same thing. I used ChatGPT, did something like, is the target point contained to answer point, and it just worked a lot better. So what I found was ChatGPT was actually very efficient for both comparing similarities and splitting text. So already I implemented ChatGPT into the first answer. ChatGPT API is pretty easy to use. One downside is that it's paid, but it's not very expensive, and yeah, I was able to implement a simple sort of, so first thing you do is split the answer. And then what we do is we just take the points. Obviously, I haven't done it for everything, but here's the example user point, what the user would give. Here's the target point on the mark scheme. Compare them using this prompt. The prompt is the information target point contained within user point? We could just give a yes or no answer. If it was, then we would be able to tick a point off, and then just say we've got the marks. So for example, on this clause, if ChatGPT says yes, we could tick it off. So that was decent. It worked all right, but one thing I found was when splitting the answer, there were still small errors, and when comparing points, we also got small errors. Like, sometimes it just said no, and it didn't work properly. So I really can't have errors when making the marker because this is the integral part of the program and it can't make errors. So this method, it was decent for the first try, but I had to do something better, which is why when moving on to V2, I actually got inspired a lot more, and I basically just fed the entire thing into ChatGPT. So inspired by this article, Automaton by ChatGPT, the teacher essentially just gives a huge prompt, giving the question, answer, mark scheme, and also student responses, and essentially asks ChatGPT to review it. Now I'll show you how this works if I can run this. I don't actually want ChatGPT to print anything though, so I'm just going to return here and print the prompt. Okay, that's just an error from before. So I'm just going to copy this prompt and paste it into ChatGPT to show you guys how it works. Okay, so let me just, right, so as you can see, I've told ChatGPT what's going to happen, provided it with the question, told it how many marks it was worth, then given it a mark scheme which has been slightly modified to try and incorporate alternatives and exceptions, then given my student response and told it to mark it. And it's actually given it in a JSON format, but essentially you can see it's taken each mark scheme criteria, told us how many marks it's achieved, given the student evidence, which is important so that we can tell the student where he got the marks. And yeah, you can see it's decent, but this method still wasn't very efficient. Like, it was, see here, an error here, reducing the force. It hasn't managed to find explicit mention of reducing force, despite the fact that in the answer, oh, okay, so yeah, I've said decrease in impact, and if you see, an alternative is allow impact for force, and yeah, I've said decrease in impact, but it doesn't seem to understand that. So this method was alright in the teacher's case because he was trying to use it to just assist him while marking, but in my case, when I'm trying to make everything fully automated, this method is not very good because there's a lot of, it's really uncertain. Like, you're basically relying on ChatGPT completely, and you don't have any control over the answer, mark scheme, or anything. So you're basically relying fully on ChatGPT, which is not a very good idea when it's a pretty, like, it's not a very standardized language model, if that makes sense. So that method was probably better than the first one, more accurate, but still not as accurate as what I wanted. So for V3, what I decided to do was essentially give all the points to the users made, so use ChatGPT to split it up, and then also split up all marking points. You can see there's also different marking points. And what I do is, let's just say I had a bunch of these marking points. These are student points, and let's say these are marking points. So what this V3 model will do is feed all of these into ChatGPT and just tell it to find which marking points correspond to which student points. So let's see how this works. Okay, so see the introduction. I've given you a list of points, student points, given you a list of marking points, and it wants to see for each student point if there's a corresponding marking point. And you can see project has decrease in impact, increase time taken to stop, so that essentially corresponds to the first marking point. Compression increases collision time, that's the second point, but it's still the same mark. therefore decrease the rate of change of momentum, third mark, but it still hasn't managed to identify this last point, reducing the force. It hasn't found it. So this was still quite inaccurate, and also this involved me having to split up the student and mark scheme points, which requires the use of AI, and again is not very accurate. So finally, what I decided on for my final idea, which still is not the final implementation, I'm planning to fine-tune this model, but the idea for V4 algorithm is that, let me just rub this out. So the idea is we're going to split the mark scheme into, well, this is a 2D array, and each row corresponds to a mark scheme point. So this entire section would be one row, and each item in the row corresponds to alternative answers. So this would be the first answer, since it's the most, this is the best one. Then we have alternative number 1, and you can see that corresponds with increased time taken to stop. Alternative is increase this time, and I'll talk about this bit later. But yeah, each row corresponds to a marking point, and then each column corresponds to an alternative answer. And it's easy to put mark schemes into this point, since mark schemes are in a standardized format, so it's easy to format these how we want, but student answers are hard to format. So that's why we've just left it as the student would give it, no splitting up, just completely normal. And what we do is we give the marking points one at a time, and we give the entire student response. So the idea is, if we have this student response and we have a bunch of marking points here, what I would do is for each marking point, I would just give the entire thing to ChatGPT, give the one marking point as well as the entire student response, and ask, is this marking point contained within the student answer? So does the student answer contain this first marking point? For example, it might say something like, does the student answer contain the point increased time taken to stop? And if it does, then ChatGPT would return yes, otherwise it would say no. It's actually a bit more than that. It says found, and then it also asks for the evidence. So if it's yes, then it would point to the evidence. And essentially what we do is we just go through each marking point trying to find where, if the student has said that, which is actually how normal examiners mark as well. Once it's found that marking point, it doesn't have to check any of the alternatives, but if it doesn't find it first, then we'll check an alternative. And the reason this is good is because, first of all, what it does is it makes sure to check all the marking points, but only give credit for that specific mark. So if you got this mark, you wouldn't get an additional mark for giving an alternative, because it's the same mark. And you can also think about exemptions, because you just don't pass them and it doesn't check for them. Additionally, if you give the entire student response, ChatGPT has a lot of context, and all it has to do is check whether this specific mark is in it, which makes it a lot more accurate than the other ones. And yeah, that's the idea. So I found this method is actually a bit more accurate than the other three, sorry. And hopefully I can show you guys it in action. So you can see I've loaded in the marking points, given a student response, and it's just going to go through each of them, ask if it's contained. If it does, then we're going to generate the response. And I've asked ChatGPT to give it in this format so it's easy to pass. So yeah, let's see what we get if I v4.py. This is going to take a bit of time because it's trying to find it, but okay, yeah, so still not 100% accurate. That's the big issue. And okay, so if you look at the mark scheme, you can see increase the time to reduce momentum for 2 marks. This would give you 2 marks. So if that was all we could find in student's answer, if all they wrote was this, we would get 2 marks. And that's the reason why I've put it in both of these points, because we're looking for it in both times. Essentially, if it finds it once, it's probably going to find it again, so we're going to get 2 marks if that's in the text. But you can see I was still unable to generate the point, generate the correct outcome, which should have been all 3 marks. So I'm going to try this again. Hopefully it works. Oh, okay. I guess ChatGPT is not feeling very good today. But yeah, this was the method which I'm hopefully going to stick to. It's just getting worse. One thing I can do to increase accuracy is probably fine-tune a model. I've been looking at, can't find it, probably haven't implemented it, but yeah, I'm basically going to create a fine-tuned model, so we're not using a regular ChatGPT model, but rather fine-tuning it to mark more accurately. Hopefully that can increase accuracy better. And yeah, that's the idea. So overall, I'm utilizing ChatGPT to mark answers and return them in a standardized format, which I can then implement into my own program. So users can input answers and get them marked by the program. So thanks for watching. That was just me trying to explain how the marking algorithm is going to work for my program. Thanks for watching, and I'll see you guys in the next video. Bye. Okay guys, just an additional cut. I realized why this wasn't very accurate. What happened was I was trying to test it if it would give still the marks for a bad answer, and so what I did was I removed some of the points. You can see that this answer doesn't actually match this because I removed the final 2 points, which makes sense why I'm only getting 1 mark, sometimes 2, because I haven't got the full answer here. So this is the whole idea why this method's a lot more accurate. Yeah, I was wondering why it wasn't working, but you'll see if I add in the extra points. So let me try and get the student answer. Okay, so this is the true answer, and you'll see if we put this in, let me clear the console and run it again. Oh, sorry, I edited some of the code. Let me just fix that. Okay, yeah, so now that I've put the full answer in, you should see that, okay, yeah, there we go. So now you can see when I put in full answer, I get all 3 points, and it's found all 3 marks, so essentially it's found all 3 of these marks, which means it's good to go. The evidence is a bit, I need to work on making it give a bit more concise quotes, but you can see for the mark point reducing the force, it's given the correct place, thus decreasing the force is in there. Mark points, so the rate of change of momentum decreases. You can see compression therefore decreases the rate of change of momentum. And finally, mark point increases the time to reduce momentum to 0. It's managed to find it here. Compression increases the time to reduce momentum. And therefore, so yeah, you can see that this algorithm does actually work a lot better than the other 3. Hopefully you're convinced of that, and yeah, this is probably the algorithm I'm going to be using into the future. Hopefully I can still fine-tune the model to do better, but thanks for watching, and yeah, that was just a small add-on.